Most people assume vision loss is a slow, unavoidable slide, something written into aging, genetics, or fate. The common belief is that once eyesight begins to decline, the only realistic response is compensation. But modern neuroscience and nutritional biology offer a far more empowering perspective. The clarity of your vision tomorrow morning is influenced by what your brain and eyes do tonight while you sleep. Your eyes are not passive lenses or simple recording devices. They are living neural tissues with enormous metabolic demands directly linked to your brain, your blood sugar balance, your circadian rhythm, and the depth of your sleep. In fact, the retina is not just connected to the brain, it is technically an extension of it. Anything that disrupts nighttime repair, elevates oxidative stress, or interferes with nutrient delivery can accelerate visual decline. Here's where things become truly fascinating. Research in nutritional neuroscience suggests that specific micronutrients consumed before sleep may enhance overnight neural repair. Calm retinal inflammation, stabilize glucose fluctuations, and support melatonin-driven regeneration. Among everyday foods, one humble option stands out for delivering compounds that benefit both sleep quality and visual health. Pumpkin seeds. Often treated as a casual snack, pumpkin seeds are biologically extraordinary. They are dense in zinc, magnesium, beneficial fats, and amino acids that the visual system depends on. Zinc is especially critical. It is highly concentrated in the retina and plays a central role in night vision, contrast, sensitivity, and protection against oxidative damage. Magnesium, meanwhile, regulates nerve excitability, supports deep sleep, and allows neural tissues to enter repair mode. This discussion revolves around a simple but overlooked principle. Eyesight support is not only about what you eat, but when you eat it. Timing matters. When nutrients are available during the brain's natural repair window, their impact may be amplified. Tonight, we'll explore how sleep, minerals, and visual processing intersect, what research reveals about nighttime retinal maintenance, and how practical food-based habits can support long-term visual resilience. When people think about vision, they imagine a mechanical sequence. Light enters the eye, the lens focuses, and an image appears. From a neuroscience standpoint, that picture is incomplete. The retina is active neural tissue, packed with mitochondria, neurotransmitters, and microvascular networks. It is constantly processing signals and consuming energy at a remarkable rate, gram for gram. It is among the most metabolically demanding tissues in the body. High metabolic activity always produces byproducts, particularly reactive oxygen species. Each time retinal cells convert light into electrical signals, small amounts of oxidative stress are generated. Under ideal conditions, antioxidant systems neutralize these molecules. But over time, if defenses weaken, oxidative damage accumulates. Cell membranes become unstable. Photoreceptors lose efficiency, and signaling precision declines. The result? Subtle but noticeable changes. Difficulty seeing in dim light, increased glare sensitivity, slower visual adaptation, and eye fatigue. Retinal cleanup and renewal don't happen evenly throughout the day. They are strongly biased toward sleep, especially deep slow-wave sleep. During this phase, the brain enhances waste clearance processes and increases antioxidant enzyme activity. Minerals are redistributed toward neural photoreceptor outer segments are renewed. Damaged components are cleared, and neural pathways recalibrate. But there's a catch. These repair mechanisms depend on the availability of key nutrients. If the bloodstream lacks sufficient minerals or amino acids during the night, repair efficiency drops. Think of it as a maintenance crew arriving with the blueprint, but missing essential tools. The process continues, but less effectively. Over months and years, consequences quietly accumulate. Zinc illustrates this perfectly. The eye contains some of the highest zinc concentrations in the body, particularly within the retina and retinal pigment. Zinc activates enzymes involved in phototransduction, converting light into neural signals. It stabilizes cellular structures and supports vitamin A transport into retinal tissues. There, it becomes retinal, the molecule essential for light detection. Without adequate zinc, the visual cycle slows and signaling precision suffers. What's rarely discussed is timing. Zinc utilization by neural tissues aligns with circadian rhythms. When zinc is present in circulation before sleep, it supports retinal maintenance during the repair window, rather than being rapidly excreted or diverted elsewhere. This is why nutrient timing can matter alongside total intake. Pumpkin seeds are uniquely suited for this role. They provide zinc within a natural matrix of fats and amino acids that enhance absorption. Unlike isolated supplements, whole seeds digest gradually, supporting a steadier release of nutrients. This steady release continues through the early sleep cycle. In practical terms, this means minerals remain available precisely when retinal repair activity peaks. Have you ever noticed your vision feels sharper after a deeply restful night and duller after poor sleep, even when your daytime diet was unchanged? That's not coincidence. It's neural maintenance in action. Early indicators of declining visual health often emerge at night. Difficulty driving in low light. Slower adjustment, moving from bright to dim environments. Increased sensitivity to headlights or screens. These are not merely optical issues. They are biochemical signals, suggesting the retina is struggling to process light efficiently. Population studies consistently link low zinc status with reduced night vision and poorer contrast sensitivity. Even mild subclinical deficiency can affect visual performance. Why? So quietly. Because zinc is prioritized for immune defense, tissue repair, and hormonal balance. Vision frequently loses the competition unless intake is consistently sufficient. Pumpkin seeds help address this imbalance naturally. Their zinc content, combined with fats that improve bioavailability, makes them a practical evening option. Many zinc-rich foods are consumed earlier in the day, alongside high-fiber meals that may reduce absorption. In contrast, a modest serving of seeds before bed digests more slowly, aligning delivery with nighttime physiology. A simple protocol emerges. Approximately 30 to 60 minutes before sleep, consume a small handful of pumpkin seeds, not a large portion, just enough to provide minerals without burdening digestion or destabilizing blood sugar. This timing allows zinc and supporting nutrients to circulate as melatonin rises and repair pathways activate. Balance is crucial! Excessive zinc from supplements can interfere with copper and iron metabolism. Whole foods rarely create this problem because they deliver minerals in proportion. This is one reason food-based strategies tend to be safer and more sustainable. Magnesium adds another critical layer. It participates in hundreds of enzymatic reactions, governing nerve function, muscle relaxation, and sleep regulation. Without adequate magnesium, the nervous system remains subtly fragmenting deep sleep, the very phase required for retinal restoration. Studies show that improving magnesium status can enhance sleep efficiency and reduce nighttime awakenings. Pumpkin seeds, rich in magnesium, provide a gentle, bioavailable source that supports parasympathetic dominance, the restorative rest and digest state. This shift is vital because chronic sympathetic activation from stress, late caffeine, or excessive screen exposure suppresses repair processes. There's also a neurochemical dimension. Pumpkin seeds contain tryptophan, an amino acid precursor to serotonin and melatonin. Melatonin is widely known for regulating sleep timing, but it also acts as a potent antioxidant within retinal cells, helping neutralize oxidative stress accumulated during the day. Even with sufficient minerals, another silent driver of visual decline is blood sugar instability. Elevated glucose, especially late in the evening, increases oxidative stress in neural repeated spikes create an environment that accelerates cellular wear. Choosing low glycemic evening foods, such as pumpkin seeds, supports metabolic stability while supplying protective compounds. Consistency, more than intensity, determines long-term outcomes. One ideal night will not transform vision, just as one poor night will not destroy it. But repeated alignment, steady mineral intake, supportive sleep habits, circadian aware, nutrition compounds, over time, vision repair is not passive. It is an active, dynamic process shaped by nightly biology, and it begins before your head touches the pillow, when you decide whether your body enters the night supported, nourished, and primed for restoration, or stressed, inflamed, and deprived of essential building blocks. Because ultimately, what happens to your eyesight is not decided only by genetics or age, but by the small, repeatable choices that either reinforce or disrupt the delicate overnight processes that keep your retinal cells functioning at their best. Processes that depend on mineral availability, oxidative balance, neural recovery, and circadian timing working together in synchrony. When we look deeper into nighttime biology, an important theme emerges. The body does not simply rest during sleep. It actively repairs and This is especially true for neural tissue. During deep slow-wave sleep, energy that would normally be spent on movement, digestion, and external processing is redirected inward. Cellular repair accelerates. Antioxidant defenses strengthen. Synaptic connections are refined. And the retina, as neural tissue, participates fully in this restorative cycle. Photoreceptor cells, responsible for capturing light, undergo continuous renewal. Their outer segments, delicate structures repeatedly exposed to oxidative stress, are broken down and rebuilt. This renewal is metabolically expensive and nutritionally dependent. Without sufficient zinc, membrane stability weakens. Without adequate magnesium, neural excitability remains elevated. Without a stable metabolic environment, repair efficiency drops. This explains why poor sleep quality often manifests visually. Morning blur, eye dryness, reduced sharpness, increased sensitivity to light. These are not random inconveniences. They are physiological echoes of incomplete nighttime maintenance. Consider the relationship between sleep, depth, and visual clarity. Fragmented sleep interrupts the slow-wave phases required for retinal repair. Even if total sleep duration appears adequate, frequent awakenings, or shallow sleep reduce the time spent in the most restorative states. The brain and eyes begin cleanup, only to be repeatedly pulled back into partial alertness. The result is cumulative fatigue at the cellular level. Magnesium plays a pivotal role here. It helps regulate GABA activity, the neurotransmitter system that quiets neural firing. When magnesium status is suboptimal, the nervous system struggles to fully disengage. Muscles remain subtly tense. Thoughts race more easily. Microarousals increase. The architecture of sleep becomes unstable. Pumpkin seeds provide a naturally balanced source of magnesium that supports this calming transition, not as a sedative, but as a facilitator of physiological relaxation. This distinction matters. The goal is not forced sleep, but efficient sleep, sleep that allows repair systems to operate without interruption. There's also a vascular dimension to nighttime vision support. The retina relies on a finely tuned microcirculatory network, delivering oxygen and nutrients while removing metabolic waste. Blood flow patterns shift during sleep, influenced by autonomic balance and metabolic stability. Elevated evening blood sugar, dehydration, or sympathetic dominance can impair this delicate exchange. This is why late-night dietary choices carry disproportionate consequences. High glycemic snacks trigger glucose spikes, followed by insulin responses that ripple through the night. Oxidative stress increases. Inflammatory signaling rises. Sleep becomes lighter. Repair becomes less efficient. In contrast, low glycemic, nutrient-dense foods support a smoother metabolic landscape. Pumpkin seeds, rich in healthy fats and fiber, slow digestion, and stabilize glucose release. Rather than jolting the system, they provide a steady stream of minerals and supportive compounds. Another overlooked factor is melatonin's protective role beyond sleep timing. Melatonin functions as a potent antioxidant within neural tissues, including retinal cells. It helps neutralize reactive oxygen species generated by daily light exposure. But melatonin production is exquisitely sensitive to environmental signals, especially light. Exposure to bright artificial lighting and blue-enriched screens late in the evening suppresses melatonin secretion. Even moderate exposure can delay its release, shorten its peak, and reduce its amplitude. The biological night shifts later. Repair windows narrow. Oxidative protection weakens. This is where behavior and nutrition intersect. Consuming pumpkin seeds before bed, while simultaneously exposing the eyes to intense screen light, creates a physiological contradiction. Nutrients may be present, but the hormonal environment required for optimal repair is compromised. A more coherent protocol lines both inputs. Dim lighting as bedtime approaches. Reduced screen exposure or use of blue light filters. A calm sensory environment. A small handful of pumpkin seeds, 30 to 60 minutes before sleep. Together, these cues reinforce parasympathetic activation and melatonin release. The brain interprets the signals as preparation for restoration rather than stimulation. Over time, this alignment influences not only sleep quality, but visual resilience. Improved slow-wave sleep supports photoreceptor renewal. Stable mineral availability supports enzymatic repair. Reduced oxidative stress preserves membrane integrity. The visual system functions with greater efficiency. Consistency transforms these mechanisms from occasional benefits into cumulative protection. Just as repeated strain accelerates decline, repeated support fosters resilience. Many people search for dramatic interventions, expensive treatments, complex supplement stacks, radical dietary overhauls, yet biology often responds most reliably to small, repeatable actions sustained over months and years. The nervous system thrives on rhythm. Repair systems thrive on predictability. A nightly seed ritual exemplifies this principle. Simple, accessible, sustainable. It requires no extreme restriction, no elaborate preparation, no pharmaceutical dependency. It integrates seamlessly into existing routines. This strategy isn't about miraculous eyesight reversal. It's about supporting processes that maintain visual function. It helps slow decline and enhance clarity within the boundaries of normal physiology. This distinction protects against unrealistic expectations while preserving genuine empowerment for your visual health. Visual health is cumulative. Every night contributes positively or negatively to its long-term trajectory. Sleep depth, oxidative balance, mineral status, and metabolic stability continuously shape retinal integrity. While pumpkin seeds are powerful, they operate within a broader ecosystem of habits for eye health. Hydration, light hygiene, stress regulation, and balanced nutrition all influence nighttime repair efficiency. Think of it as constructing a supportive environment rather than chasing isolated fixes for your vision. The retina doesn't fail overnight. It adapts, compensates, strains, and gradually signals imbalance. Night vision softens, glare intensifies, contrast dulls, often before clinical disease appears. Neural tissues retained remarkable adaptability when given consistent support for visual health. Even after years of suboptimal habits, improvements can positively influence function. Sleep quality, metabolic stability, and nutrient timing are key factors for better vision. Your visual system is not static. It is responsive, dynamic, and continuously renewing. This leads to a powerful shift in perspective for eye care. Instead of asking, how do I fix my eyesight? Ask, how do I support my eyes every night for efficient repair? That question redirects attention toward behaviors you can control for better vision. Bedtime regularity, evening light exposure, stress levels, late night food choices. These are small levers with outsized long-term impact on your visual health. As these patterns stabilize, people often report subtle but meaningful changes. Less morning eye strain, smoother dark adaptation, reduced visual fatigue, greater comfort during nighttime driving. Not dramatic overnight transformations, but gradual recalibration. Sustainable physiological change rarely arrives as a sudden leap. It unfolds as a quiet, steady progression. The science of circadian biology reinforces this. Cellular repair follows rhythmic cycles. Disruption, irregular sleep, inconsistent meal timing, erratic light exposure, weakens efficiency. Alignment strengthens it by pairing a mineral-rich, low glycemic evening snack with calming environmental cues, you create a coherent signal. It is time to restore. And the body, evolved over millions of years to respond to such signals, adjusts accordingly. Which brings us to the final and perhaps most practical insight. The effectiveness of any vision support habit depends less on perfection and more on persistence. Not flawless nights, but consistent direction, because it is the accumulation of aligned evenings, not isolated efforts, that shapes retinal resilience, neural efficiency, and long-term visual stability. Stability that emerges when sleep, nutrition, and circadian timing repeatedly work in harmony, night after night, gradually reinforcing processes that preserve clarity, protect photoreceptors, and sustain the delicate biochemical choreography required for vision to remain sharp, comfortable, and responsive. Even as the years advance, lighting conditions change, and visual demands increase. By now, a central theme should feel unmistakable. Vision is not maintained by chance. It is sustained through biology, and biology responds to patterns. The retina is living neural tissue, continuously renewing, continuously adapting, continuously influenced by the conditions you create, especially during sleep. Let's bring everything together into a clear, grounded framework. First, understand the nature of visual wear and repair. Every day, your retinal cells convert light into neural signals. This process is extraordinary, but metabolically expensive. It generates oxidative stress, consumes micronutrients, and challenges cellular stability. By evening, your visual system is not merely tired, it is biochemically taxed. Nighttime is when restoration is scheduled to occur. Photoreceptor components are recycled, damaged molecules are cleared, antioxidant defenses are replenished, neural signaling pathways recalibrate. But these processes are conditional. They depend on deep sleep, stable blood sugar, and sufficient mineral availability, and a circadian environment that permits melatonin to rise naturally. When those elements align, repair proceeds efficiently. When they don't, maintenance becomes incomplete, not catastrophically at first, but cumulatively. Second, recognize the leverage of timing. Nutrients consumed in the evening are not just additional fuel. They are inputs delivered directly into the body's primary repair window. Zinc supports the visual cycle and membrane integrity. Magnesium supports neural relaxation and sleep depth. Tryptophan supports melatonin synthesis. Antioxidants counteract oxidative byproducts. Pumpkin seeds deliver this combination in a remarkably elegant package. No synthetic stacking. No excessive dosing. No disruption of mineral balance. Just a naturally coordinated matrix of supportive compounds. Third, appreciate the role of metabolic stability. Late-night spikes in blood sugar amplify oxidative stress and fragment sleep architecture. Even small, repeated elevations create an environment where neural tissues face increased pressure. Choosing a low glycemic evening snack shifts the trajectory. Instead of stress signaling, you promote stability. Instead of disruption, you encourage repair. Fourth, protect the hormonal repair signal. Melatonin is not only a sleep hormone, it is a retinal protector. Artificial light exposure, late at night, suppresses its release, narrowing the biological window for restoration. Dim light is not a lifestyle aesthetic. It is a biochemical strategy. Fifth, anchor everything in consistency. Biology thrives on rhythm. Repair systems strengthen with predictable patterns. The power lies not in intensity, but repetition. A single supportive night is beneficial. Hundreds of aligned nights are transformative. This leads to a practical protocol that is both simple and sustainable. Establish a consistent bedtime whenever possible. 30 to 60 minutes before sleep, consume a small handful of pumpkin seeds. Keep the portion modest, enough to nourish, not overload. Dim lights as the evening progresses. Reduce or soften screen exposure. Avoid late, high-sugar snacks and stimulants. That's it. No extreme diets, no complicated regimens, no dependency on expensive interventions. Just a nightly alignment of nutrition, neurobiology, and circadian rhythm over weeks and months. Such alignment may support more restorative sleep, reduced morning eye fatigue, better dark adaptation, maintained contrast sensitivity, and greater visual comfort. Not because pumpkin seeds are magical, but because they support mechanisms. Your body already uses mechanisms that function best when given the raw materials and conditions they require. There is also a deeper psychological shift embedded in this approach. Instead of viewing vision decline as inevitable, you begin to see visual health as something dynamically influenced by behavior, not fully controllable, but meaningfully shapeable. This shift matters. It replaces helplessness with participation, passive concern with active support, fear with strategy, and importantly, it aligns expectations with physiology. You are not forcing change. You are facilitating repair. The retina, like the brain, retains a degree of plasticity throughout life. While no food or habit can guarantee perfect eyesight or reverse all pathology, supportive routines can influence resilience, efficiency, and the rate at which stress accumulates. Small nightly advantages compound, just as small nightly disruptions do. Think about the asymmetry of time. Visual decline often unfolds gradually, almost invisibly, until one day, night driving feels uncomfortable. Reading requires more effort, glare becomes intrusive, but improvement and protection follow a similar curve. Subtle, incremental, then noticeable. Clearer mornings, less strain, greater stability. Finally, consider the broader implication. Your eyes are not isolated organs. They are part of your nervous system. Supporting retinal repair supports neural health. Supporting neural health supports sleep. Supporting sleep supports metabolic balance. Supporting metabolic balance supports long-term vitality. This is not just about seeing more clearly. It is about living within rhythms. Your biology recognizes rhythms that govern restoration, resilience, and long-term function. So tonight, you are faced with a remarkably low-effort opportunity. A small handful of pumpkin seeds, a calmer, dimmer evening, a consistent transition into sleep. Simple actions that signal the body repair can begin. And while the results may not shout overnight, they whisper through accumulated nights. Nights in which your brain and eyes receive the minerals, stability, and conditions needed to renew delicate structures, neutralize oxidative stress, recalibrate neural processing, and preserve the clarity that allows you to move through the world with comfort, confidence, and visual ease. Vision support does not start in the clinic. It starts in the quiet choices made before bed. And it starts again tomorrow night.